Hey guys, I've really been enjoying making the teardown videos of various battery packs, and it seems like they go over fairly well with my viewers. So I started taking a look around to see what else I can pick up and tear down to show you what's inside. One of the deals I came across recently is these Ryobi 40-volt lithium battery packs. They're for power tools. They were selling for $6 on the BatteryHookup website, so I bought a box of 5 of them. And of course, like every other BatteryHookup order, you get to experience the lovely anti-static packing peanuts. See how anti-staticky these packing peanuts are? They are wonderful to clean up. I'm going to go get a shop vac and I will be back. And there are supposed to be 20 Samsung or LG 18650 cells inside. The cells we usually get from power tool battery packs tend to be lower capacity but high discharge rate. So they're great for things like e-bike building and building or replacing other power tool packs. So we'll start taking this apart and see what's inside. So I see there is 4 terminals here. There's a minus and a T1, T2, and a plus. I'm guessing the T1 and T2 is some sort of communication. So we'll stick the multimeter on the positive and negative and see what the reading is. And we got 1.53 volts. So to open this battery pack, you'll need a T15 Torx, and there's supposed to be a total of 6 Torx screws. I see 2 here, 2 down here, and then I believe there is some underneath the label. You'll need a T15 security Torx, and the security Torx basically means there is a hole in the end, and that hole lines up with the stud on the Torx screw. This is also called a tamper-proof Torx. You may see both of those marketing terms when you're in the hardware store looking for them. Alright, with those 4 screws out, let's see if we can get the label off here. Do not see any screws under that. So, alright, so I can't find any other screws, so we're just going to try to pry it and see what happens here. So, you can see it wants to come a little bit. Alright, I guess there is only 4 screws. Alright, so here's the inside of the battery pack. I see they are LG cells. They are the LG DAH A11865. I was kind of hoping for Samsungs. I have a lot better luck with Samsungs than LGs, but LG is a very reputable brand as well. So looking at the PCB, I'll be honest, I don't know what I'm looking at. There's a ton of components here. This is likely the balance lead coming in. I see these are the terminals that would connect into the power tool or the charger. And then on the back here, there is a very large heatsink that goes down in there. I'm going to guess that's the MOSFET that's controlling the power on and off. And I do want to say too that these batteries do put out a ton of amps, so you cannot, under any circumstances, touch the stuff that's in here until these batteries are disconnected, and you need to do so in a very careful way. Some people are more susceptible than others to lower voltages. It all depends on your body type, how much moisture is in your skin, etc., etc. So first I'm going to go ahead and remove the batteries from this bottom case. There's probably some glue on the bottom. You know what? It feels like there's screws. There's the other 2 screws they were talking about. You can feel when you run your finger of it, there's something under there. So let's get that label up. Alright, so those are regular Torx, not security Torx, and they're quite a bit smaller than T15. So this is a T8 Torx. It's also a security Torx, but you won't need the security Torx part for these screws. Alright, with those 2 screws removed, let's see if we can pry it out again. So, take the common. There we go, it popped out. Guess we'll begin by unplugging. And that was not the BMS lead, so I guess I was wrong. It looks like that is the button for the front that has a test light and shows you how much power is in the charge. So there's 4 LEDs and then just the push button. So each one of these larger solder points is most likely where the BMS is attached. So we'll start by removing all the Phillips screws that are holding this BMS board to the battery pack. And it looks like most of those are number 1. Again, you need to be extremely careful not to short anything out in this battery pack. Alright, and most likely that's still being held on by the solder points, which I can see under there. This rubber thing comes off. Oh, there's some Torx bits in the end as well. There's two Torx drivers here. And the T15 Torx will work for those as well. Oh, those long screws. Alright, so there is two methods to getting the cells out of these holders. You could take a soldering iron and remove all of these solder points where the nickel strip solders to the PCB. There's like 10 of them or so. Or you could use my favorite method of the tear it apart method. Of course, the tear it apart method only works if you do not intend to reassemble this later, which I don't. So I'm going to show you the tear it apart method today. We're going to start by removing the heatsink for the MOSFETs here. You'll need a number 2 Phillips. There's 2 screws on the top here. And then once you have the MOSFET screws removed, you can use a pair of long nose and bend down the PCB. Now, of course, if you do want to reuse these MOSFETs, you could unsolder the MOSFETs from here. I have no use to reuse these, so I'm just going to toss them out. So the other thing is you'll find over here is a temperature sensor. If you peel back this adhesive stuff here, temperature sensor is floating around in there. I do know some people reuse these temperature sensors. I do have a bin of them. I'm just not sure what to do with them. So I have been saving them this far. If anybody knows the best way to reuse these temperature sensors, definitely let me know. I'd be curious to see what you're doing with them. So underneath where the MOSFETs were, you'll find 2 more T15 Torx screws. So once you take out all 4 of those Torx screws holding it together, the PCB does want to bend. But we don't want to bend and break it yet, because remember, all this stuff is still electrically connected up here. And bending it and breaking it, you don't know where the points are going to break and what's going to short out. And with these being high discharge cells, you definitely don't want to mess around with that. So before we do that part, we're just going to go through and pick off all the spot welds from the top of these cells. So I found the best way to do that is just to take a small flat tip screwdriver. On the negative ends, you can just slide it under and pry them up. They break fairly easy. Remember, it's just nickel connecting them together here. And then I found on the positive ends, the best way to do it is to flip the tabs up like this at the ends of the spot welds. So you'll see how I'm flipping it up a little bit. Maybe this view is a little better. You see how the nickel tabs are flipped up on both of these ends. So once they're flipped up, you can take your small pair of snippers or snippy tools or dikes or whatever you call them and just peel them back. And they come off very easily as well. One thing you'll want to keep in mind with these power tool battery packs is the spot welds are usually a lot stronger than on laptop batteries, and you want to make sure as you're removing these nickel strips that you do not make a hole in the cell. If you accidentally make a hole in the cell and you smell the electrolyte, you need to throw it out immediately. I usually keep a bucket of sand around. I'll put it in the bucket of sand. I've also heard of people throwing them in buckets of water, which helps discharge the cell as well. So if you do get one where it doesn't peel back perfectly like this, the snippy tool, again, they snip very easily. There's just thin pieces of nickel connecting these cells together. Alright, so these are positive cells here, so I'll flip up the ends. Just peel them all back. And I'll do the same with the end over here. Again, positive ends. You need to be careful you're not shorting these out as you're sticking metal objects in here, but it is a little bit difficult to do because these two cells are connected in series. So if you touch these two together accidentally, they're already electrically connected anyway, so nothing's going to happen. The same with over here, these two are connected together, and then this one is on its own, so you want to be careful not to accidentally short it out this way or this way. But the places you're sticking the screwdriver are in towards the area which is connected to the adjoining cell, so it is difficult to accidentally short them out. Go up the negative side, being careful not to dent the cell. Remember, you just want to remove the nickel strips. Pop right off. Double check that you got them all and that there is no nickel attached. And then we'll move on to the other side and do the other side the exact same way. Alright, so once you have the other side done, just verify again on both sides that there is no nickel left connected. And I call it the break it apart method because you're going to take the battery and break it apart like this. Alright. So now that the pack is broken apart into two, again, same as before, we're going to pick off all these spot welds. And once you have the welds off on the other side, you should be able to pull apart and get the cells out. So it may take a little bit of effort, and channel lock pliers are a good idea. Yeah, so that would have been a lot easier if I wasn't also trying to film it. That's one of the reasons why you saw me struggling so much. So once you get your cells out, there's all these little tabs you'll have to pick off the end. And the best way to do that is just to take, again, your snippy tool, just peel them right off. They'll break right off. This is also a good time to inspect for any punctures that may have occurred while you were taking apart the batteries. And it's not punctured, but I did gouge this one a little more than I liked. You need to be careful when using the flat tip screwdriver to peel off those spot welds. And then you'll probably still have some burrs left sticking up. The best way I find to take care of those is just to take the flat side of your pliers and just tap them down flat. And then go through all your cells and do the same thing. Alright, just need to clean up the work area a little bit here. So those metal shards will hurt if they go in your foot. Alright, so here are the 20 LG 18650 cells. So we got 0.13, 0.17, 0.16, 0.13, 0.15, 0.19, 0.16, 0.1, 0.13, 0.09, 0.19, 0.14, 0.19, 0.16, 0.13, 0.15, 0.15, 0.07, 0.19, and 0.09. So the good news is they're not at 0.00 exactly, so we know they are not self-discharging yet. But that voltage is extremely low for an 18650 cell, and damage could be occurring already, but a capacity test will reveal any problems. So because the voltage of these is so low, I'm going to have to pre-charge them before I can put them in the Opus chargers, and to do that I'll be using my TP4056 charging boards. Alright, so unfortunately I only have enough space to charge 16 cells at a time because I didn't finish building the remaining charging boards yet. So I'll let these pre-charge up. I'll come back and do the last 4 later. And then hopefully tomorrow we'll be ready to put these on the Opus chargers and see what the capacities are. Alright, so all these cells finished charging last night with the TP4056. I also did finish opening up the remaining 4 Ryobi batteries last night. 4 of the 5 were LGs. And then I did get one of Samsung's. They are INR 18650 13Q. Alright, so I got all 20 cells in the Opuses. They are testing at 1000 milliamps. I did look up the specs online. They are 1300 milliamp hour cells, which the lower capacity is typical for high drain power tool type batteries. So yeah, we'll be back in a couple of hours and see what the capacities are. Alright, so here are the results. Most of them are in the 1100 range. There are a couple 1000s. There is one that says null. I think that slot's bad. Yeah, it was testing before, but it needs cleaned out. So that's not a bad battery, that's a bad slot in the charger. So I did do a little bit of maths, and the average capacity amongst these cells is 1109, and that means they have about 85% of the original manufactured capacity. That is outstanding in my opinion, considering these are used power tool batteries and you know they've been abused throughout their lifetime. So I don't know that I'm going to put them in my power wall considering they are high drain, low capacity cells, but I definitely will find a use for them. If you are interested in buying any of these batteries, they are still on sale for $6 a piece, and if you use coupon code BATTERY, you can get an additional 10% off, which brings the total down to $5.40 per pack. This was not a sponsored video. I bought these batteries with my own money, specifically for this test. However, when you do make a purchase using my link in the description below, I do receive a small commission, which I do use to go out and buy more batteries to continue making more fun videos like this. I do want to know as well if you enjoy seeing these sort of teardown videos. I know I have a lot of fun making them. Please let me know in the comments below. And if there's any specific piece of equipment or battery you want to see torn down, let me know that information as well. Otherwise, don't forget to like and subscribe, and thank you very much for watching.